Welcome to Crackit. Today we are going to discuss about HashSet versus TreeSet. This is a frequently asked interview question. Let's go to the discussion. What is the data structure that is used in the HashSet? The underlying data structure that is used in the HashSet is the hash table, and this provides us an efficient add, remove and search operations. Also, this HashSet is one of the most used implementations of the set interface. Tree set. The underlying data structure of the tree set is the red-black tree data structure. It is nothing but a binary search tree which will automatically restructures itself to maintain the balance of the tree so that the height of the tree remains algorithmic. So this is the HashSet class from the Java. We can see that HashSet uses the hash table data structure, whereas if we open TreeSet, that is using a navigable set and that is based on the implementation of a tree map. And if we open tree map, we can see that that is a red-black tree implementation. This is what we discussed in the previous slide. The time complexity of HashSet is order of 1, whereas the time complexity of the tree set is order of log n. Both of these time complexities is based on the underlying data structure that is used. So the performance of the HashSet, if we go and see, HashSet is always faster than the tree set, but tree set is comparatively lower. Why it is lower? The tree set always stores its elements in the sorted order, which will take some time. Also, the HashSet uses the equals method as its comparison method to compare two objects for the identifying duplicates, whereas TreeSet method uses compare two methods to identify the duplicates. If we see the HashSet class, we can see that this is using equals method for its comparison, whereas the TreeSet is using compare to method. HashSet will allow null values, whereas TreeSet won't. Why? Because TreeSet will throw null pointer exception because it is using the compare to method for its comparison. This compare to method will throw null pointer exception. Also, when it comes to ordering, HashSet does not maintain any order, whereas TreeSet that maintains the sorted order, and this sorting is based on the comparable or the comparator interfaces sorting method. Regarding the object types, HashSet allows heterogeneous objects, whereas TreeSet will not allow heterogeneous objects. It will throw class cast exception. We have implemented example for these last 3 points for the better understanding. We'll discuss that now. This is our example. If we see, we have a Crackit class wherein we have ID and playlist as the data members and the corresponding getters and setters for it. So we are creating two objects for Crackit and we are adding that to the HashSet and the TreeSet. Let's see what happens. If we run this program, we can clearly see that while adding it to a tree set, this is throwing an exception, class cast exception, and saying that this is java.lang.comparable interface is not available. So if we go see the Crackit class, we are not implementing the comparable interface. Now we have uncommented the implements comparable and we are overriding the compare to method. Why this tree map is throwing exception? Why? Because tree map stores its elements in the sorted order, and for that sorting to happen, we need to implement this comparable interface. So now if we run this program, it will not throw exception. Also, our next point was HashSet will allow nulls, whereas TreeSet not. Let's try that as well. So if we run this example, we can see that null is allowed in HashSet but not in the TreeSet. Why? This TreeSet will throw null pointer exception. Why? Because the compare to method will throw the null pointer exception. Our next point was about the heterogeneous objects. Let's see what heterogeneous is. If we see here in our HashSet, we have this Crackit and Crackit1 as the objects of this Crackit class, whereas this one is an integer. HashSet will allow this mixing of this object, 2 being Crackit and 1 being integer, whereas TreeSet will not allow this type of heterogeneous objects. Why? Because TreeSet is comparing its one object with the other to store its elements. It cannot compare two incompatible types. That's why TreeSet will throw the exception. We can see that. So if we see here I'll comment this. If we see here, this will throw class cast exception now. Why? Because it is not able to cast this integer class 1 with the Crackit. We can also verify about the insertion order by executing this example. So when we run this, we can see that the hash set is not maintaining any order. Why? Because like we have inserted crack it first and 1 in the last, but we can see that null is printing first and 1 as the second element. So hash set will not maintain any order, whereas tree set will maintain sorted order. So if we see here, this is based on the IDs. Why this is based on the IDs? Because we have provided ID in our compare to method. Thanks for watching Crack It. Please do like, share and subscribe.